S3 has been involved in more AWS data breaches than any other service. Capital One in 2019. Twitch in 2021. Countless startups that never made the news. And every time, the root cause wasn't that S3 lacked security features. AWS has added layer after layer of protection over the years. The problem is that S3 is used for everything: file sharing, static websites, log storage, data pipelines, and each use case pulls access policies in a different direction. Today, we're walking through every layer of S3 security so you can lock your buckets down properly. Let's start with block public access. AWS introduced this in late 2018 after a wave of bucket exposure incidents. It operates at two levels: account and bucket. You should always start at the account level. There are 4 settings. Block public ACLs rejects any put request that includes a public ACL grant. Ignore public ACLs nullifies existing public ACLs without deleting them. Block public policy rejects bucket policies that would grant public access. And restrict public buckets limits cross-account access on buckets that have public policies. That last one is the most misunderstood. It catches a class of misconfiguration where a policy meant for one external account accidentally grants access to everyone. Enable all 4 at the account level with a single CLI command, and you've prevented the most common category of S3 breach. Next up, ACLs versus bucket policies. S3 launched in 2006 with ACLs as the only access control. Bucket policies came later. For years both coexisted, and the effective permission on any request was the union of the ACL and the policy. This caused massive confusion because teams would write a restrictive bucket policy, not realize an ACL was granting broader access, and think they were secure. Since April 2023, new buckets default to ACLs disabled, which AWS calls bucket owner enforced ownership. But older buckets still have ACLs active. You should audit every bucket in your account and set ownership to bucket owner enforced. The one exception is if you're using S3 server access logging, which still requires an ACL grant to the logging service. For that case, either keep ACLs on the logging destination bucket only, or switch to CloudTrail S3 data events instead. Now let's talk bucket policies. A production bucket policy should enforce HTTPS-only access at minimum. You do this with a deny statement that triggers when the SecureTransport condition is false. But here's a mistake I see constantly: the policy only includes the object-level resource, the bucket name /star. That protects getObject and putObject, but it doesn't protect bucket-level operations like listBucket, which use the bucket ARN without the /star. You need both resource ARNs in your policy. Without both, an attacker can enumerate your bucket contents over plain HTTP even though they can't download individual objects. For sensitive buckets, add a VPC endpoint condition so the bucket can only be accessed through your VPC's S3 gateway endpoint. Even if credentials leak, an attacker outside your VPC can't reach the data. Encryption. Since January 2023, all new S3 objects are encrypted with SSE-S3 by default, that's AES 256 with AWS managed keys. So encryption at rest is no longer optional. But SSE-S3 has real limitations. There's no audit trail of who decrypted what. You can't disable the key to revoke access. You don't control key rotation. And many compliance frameworks require customer-managed keys. For anything beyond basic storage, use SSE-KMS with a customer-managed key. Now here's the critical detail: always enable BucketKeyEnabled. Without it, every put object generates a separate KMS API call. At 3 cents per 10,000 requests, a bucket handling 1 million objects a day racks up serious charges. BucketKeyEnabled tells S3 to generate a short-lived bucket-level key from KMS and reuse it, cutting KMS costs by up to 99%. One Boolean flag, massive cost difference. Monitoring. Enable CloudTrail S3 data events to log every getObject and putObject call. This costs 10 cents per 100,000 events, but it's invaluable during incident response. You can query these logs with Athena to answer questions like, who accessed this object, when, from what IP, and did they succeed? Beyond data events, set up event bridge rules to catch configuration changes. Any manual change to a bucket policy, encryption setting, or public access block should trigger an alert. In a mature environment, these changes only happen through Terraform or CloudFormation, so any direct API call is suspicious. Connect these alerts to your Security Hub findings from day 11 for a single pane of glass. Finally, versioning and object lock. Enable versioning on any bucket storing data you can't regenerate. It protects against accidental deletion and overwrites. But add lifecycle rules to control costs. Without them, old versions accumulate forever. Object lock goes further by making objects immutable for a defined retention period. Governance mode allows override with special permissions. Compliance mode is truly immutable, even the root account can't delete objects before retention expires. Choose carefully. Tomorrow we're diving into AWS KMS and encryption key management, which ties directly into everything we configured today. Hit subscribe so you don't miss it.